Recently, I built a game called Brain Wars, which is a multiplayer AI based quiz game. In this video, I wanted to demo the game as well as go through the design and how I implemented it, what are the things I did right, what are the things can be improved. Let's get started. First, let's look at the demo of this game. This game is live. So, first, I'll go to the link and then sign in. So, once I sign in, I can do a multiplayer game, and then there can be multiple bots which can play along with you. Suppose I take 10 seconds, 15 seconds, and 20-second bot, so it automatically picks an answer in the 10th second, 15th second, 20th second based on how you play the game. Suppose you played really well, it picks the right answers, and then based on how you perform, it just picks random answers, and then you can just type in a topic which you wanted to play game, or let the system decide and choose a random topic. And for this game, I have chosen 3 questions and then time limit of 2 per question, and then the difficulty level is easy. So first I would create a game room here. Once the room is successfully created, you can see the room has been created here. So once the room is created, I will go join this room with the room code. You can see the bots are already in the game, and then you have joined. I would go and join with another account. You can see I have joined as well as the other account has also joined the game. We can use the chat as well. And then once everybody is ready in the lobby, you can see void clicks ready, and then once everybody is ready, I'll start the game. And the start game button is, suppose one of your friend isn't starting the game, you can just force start this game, or you can leave the game. So once everybody is ready, the game automatically, battle royale automatically starts. It is setting up the game, and you see you start getting questions on a random topic. I pick an answer. As far as you see, that bot is simultaneously playing with us. The leader, suppose you answer a question and you see your co-player Void hasn't answered. If you try going to the next question, you can't proceed because it is in battle royale and everybody needs to work together. But once the time gets over, it automatically moves to the next question. So for every correct question, you see the leaderboard shuffles, and once all question is done, you see the live leaderboard here, and you can analyze the game. So the 10-second bot has chosen a wrong answer. I have chosen tiger. The 15-second bot has chosen wrong answer, and the other player has chosen the right answer, and so on. You can analyze this anytime. This is a small demo of this game. Now let's see how I built it and what are all the features that are in there. So it all started with some kind of a rudimentary sketch which I did when I was free. So I wanted to have this game where there is single player and multiplayer, and there is a bunch of bots which you can play along, and eventually you start the game and play. So I refined this idea to something like this. You are able to create rooms, and you can play either single player or multiplayer, and then based on the type, if it is a multiplayer, you create some kind of a room, and then you stay in a lobby, and then start the game, play the game, and then you finally generate some kind of a report. So after the initial idea, I refined it to this idea, and I made sure that even though it is single player and multiplayer, the way things work and the code has to be very similar, and just the nature of the game needs to change, but overall code should be similar. So there is this separation here. Either if it is in single player, you directly start a game, or you go create a room and join a lobby, and after that, the moment game starts, everything flows, even though it is single player or multiplayer. This is the overall design. The first layer is the auth layer, and I have used auth0 for my auth. The reason why I didn't roll my own auth, even though there are videos in my channel itself, the reason why I didn't do it is because I wanted to focus more on building the core product rather than sitting and working on auth. And I know I hardly will at max reach few thousand users, and few thousand users are free in auth. I think at least until 10,000 users it is free in auth0. Plus auth0 documentation is beautifully written, and it is very simple, and it works seamlessly with Golang. If you are building app in Next.js or TypeScript or something like that, you can check out Clerk as well. Then there is this rate limit layer. I just placed it here, but it doesn't technically lie here. It just lies across this app. So basically what I did is, this app involves this AI component of generating questions and so on, and at times it gets costly. Even though I tried using a lot of free models, suppose I use here I use 3 models and all are free, but suppose all 3 models are busy, or if it is some kind of a peak time, it just goes to the 4th model, which is a paid model, and then it generates the quiz data from that model. So it can quickly become a bit costly. So what I did is I did this overall rate limit, where a user can play for I can create room thrice and play thrice, at least for the beta version. So that's the rate limit layer here. After that, there is this front end. This front end is it is written in plain HTML, CSS, JavaScript. HTML, Tailwind, JavaScript. And if you would have seen the demo, I think it looked clean. Even though it is not a 2025-ish very modern design, it did serve its purpose. So I felt that I'm very comfortable with all these 3, and I also used HTMX here, MX for few Ajax calls. So since I was very comfortable with this, and it is very simple to debug for me if there is a problem in JavaScript, so I chose this tech stack here. So basically you select a single player or multiplayer, and then I mainly used WebSockets here. I had 3 options here. So how do you usually proceed when you wanted to build a multiplayer app? 1, you can do something called short polling. 2, you can do something called long polling. There is something called server side events, let's see later. And then the third idea which I can use it here is WebSockets. Each has its own advantage and disadvantages. Suppose first let's see what short polling is. Assume this is user 1, this is user 2, and this is the server. So now in short polling, what you do is you constantly request for data. Suppose this player has played and did a move or answered a question. You want the other guy to know he has answered, and update the leaderboard and do all the usual quiz stuff. So what you do is you constantly keep polling the server, waiting for some kind of a response from the server once this user has submitted. Similarly, if this guy answers something, the other guy keeps constantly polling for result, asking the server if anything has changed or not. Once something has changed, he gets the result back. What is the advantage and disadvantage? The one huge problem is you keep hitting the server again and again and again and request for results, and this will increase the load on the server. The another Another reason is you keep hitting the server, you tend to eat up lot of bandwidth, network bandwidth, which is also a very important consideration which we need to do here. Usually for my app, for my use case, I would at max have like a few thousands, like a few thousand users or a few thousand lifetime users, and for this use case, short polling is more than enough. But since I wanted to explore how building with WebSockets, I chose that. The next one is long polling. So why long polling is not ideal for me is, so first let's see what long polling is. So the same case, two users and there is this server. Now in short polling you keep hitting the server again and again, but in long polling you ask for some value and wait until you get some value. Suppose player A, player B, you ask the server the result of player B, and you keep waiting for it until it sends a result back. This is a very layman term of saying you keep waiting for it. It basically you wait for a certain time until you get some result, and then you come back, do it again, over again and again and again. So in short polling you keep bombarding with requests. In long polling you send a request, wait for some time, and get back the result. The disadvantages with this is it is slightly complicated to implement because there is this intermediate time between you sending this request to the server and you getting back the response. Suppose you have thousands of clients. Each client is requesting for some data, and since the request isn't completed immediately, you see this multiple HTTP connection has been opened and it is all waiting for the data. This is one problem, the main problem in long polling here. And the third method is WebSocket, which I use. Even WebSocket has a lot of problems. We will discuss them. So suppose there are 4 users in our game. You see in multiplayer there are multiple users connected. So what happens is all 4 users are connected together in a WebSocket connection. And when a guy sends a message, based on your logic, you can directly transmit to the other users. So here the message transmission happens bidirectional. So the user can send message and it can receive message. It doesn't need to go and ask out for message. In all 3 methods, you might think this WebSocket method is like a no-brainer method to use, right? Because you don't have to keep requesting for information. It just automatically comes to you. But the thing is, WebSockets are stateful. You 4 guys are connected to a server. That means you have a same connection. What if this server goes down? Take an example of a long polling or a short polling or whatever. Users request for a bunch of data. If the server is down, you can horizontally scale the server and keep asking for the same data, because these requests are stateless. You have all the data in the request, and these data is enough for you to get back the answer. You ask for something, you get the result. But it is not same with the WebSocket connection, because it is stateful. It just needs the connection, and all these users are connected together with this connection. Technically all these 4 guys have the same connection and we pull them together. So it is possible to scale WebSockets as well. Assume there are n users and 4 users play together. So 4 users should be connected together, and this connection needs to be stored, so that once you receive data from something, you need to use this connection and send data back to other users. Suppose these 3 guys are in some other room, you will have a different connection. and you need to maintain this connection. And most probably the connection will be in a machine. What if it suddenly goes down? That means we lose this connection, and we need to write all sorts of logic to make sure we have this connection alive. And then most importantly, you need to write a manager logic to manage all these connections. Whom do you send a message, what kind of message you will send, what kind of event it is, and so on. So there are a lot of things that needs to be considered while setting up a WebSocket connection. The first thing I did is created something called event pool. We created a WebSocket connection and we group people together. You can use this pool for different reasons. You can create different events and utilize these WebSocket connection. Suppose in the game we have three main component. One is the questions. It is not three. Wait, I think it is more than three. One is the question. Another is the answer which each guy answers. Another is the leaderboard, and another is the chat. You can group different data which comes from the backend or between the users into different categories called events, and you can write separate logic for each events. Suppose for the questions, so my backend will give a question event with the question, and once the UI receives it, it sees an event called question, place the question, and once some user is submitting the answer, it goes back to the server in an event called answer, and the server reads this answer event and does what it needs to do, that is calculate the score. And similarly, after calculating the score, it sends back as a leaderboard event, and then because of it tagging it as a leaderboard event, the UI knows what to do if it gets data tagged under leaderboard event. Similarly for chats as well. So this was easier for me to do all the things that I wanted by creating these event pools and segregating different components here. And I forgot to add the main component here, the AI component. Based on the prompt, our app goes and fetches the questions from the LLM. At first I used Gemini 2.5 Flash, I think 2.5 Pro, and then later I felt that what if it gets costly? I need to come to the server, swap the Gemini key with DeepSeek key or ChatGPT, OpenAI key. I went ahead and used OpenRouter. So OpenRouter is this AI inference provider where it has like every model available on internet. You can just pick and play the model which you need, and OpenRouter gives you one single API key. In what I did is in OpenRouter I have chosen DeepSeek R1 Sarvam. I chose Sarvam because a lot of people who uses are heavily into Tamil, and I was pretty much sure that they would go ahead and ask few Tamil quizzes to generate. So I had Sarvam in it, and if all the three doesn't work in the sense, suppose they hit my users comes in peak time, since all these three models are free, very rarely all three are busy. The probability of all three not available at the same time is quite high. So as a backup, I had Gemini 2.5 Pro. So now what happens is OpenRouter has this routing strategy which you can enable in their API, that you can route it based on cost. Suppose you have three models which are priced differently, you can always choose the one which is cheaper, or the one which is costlier, or the one which is maximum available at the time, and so on. There are different ways you can categorize, and different way you can access the data here, and all these things you don't have to write it on your own, and Open router has the API. You just need to enable it, and most of us developers need a result in the form of JSON, so that we work on the result, we fetch the data and so on. But if you wanted to natively do this, you need to be really good in prompt engineering and force the model to send you as JSON, which 80% of the time it does well. But if it is this kind of a free model or a very basic model, a lot of time it misses out. So this open router has this different parameters to set kind of data you need from the LLM. Even though my prompt anyway says return me as JSON in a certain format, there is this double check where I add the same return as JSON in the open router as well. So that's the reason why I use open router. Suppose someday you switch on Gemini 2.5 Pro and people started using left, right and center. All you need to do is switch this off an open router, go for something cheap like Gemini 2.5 Flash. You don't have to change the API key. Some of us use this .env file, which I don't recommend, but if you use .env file for password, .env file for secret, now the secrets are in your environment, so just changing the API key in env file isn't enough. You need to restart the whole game. So to avoid all these confusions, I went ahead with open router. So I used an Nginx reverse proxy. Why? There are many reasons. So this is the front end. This is my VPC. So I wanted to expose this VPC via Nginx. Since it's a reverse proxy, it is in the VPC. So the front end reaches Nginx. Nginx reaches my backend server. So the reason why I used is you can even rate limit at Nginx, and Nginx has a lot of features which I can use it in the future. Mainly now I use it for TLS SSL, and then I use some rate limiting. Even Nginx can do load balancing, like it can implement various kind of load balancing algorithm like round robin. Then what next is my Golang backend. So the whole logic revolves in this Golang backend. So how I designed this, these bots are very similar to players. 10 seconds, 15 seconds, 30 seconds, and these are the real players. The only difference between these bots and the real players is they don't have to communicate with the front end. They just need to work in the back end, and that's it. So what I did is, the whole process is very similar to that of users, except the certain parts where it creates an WebSocket connection and it needs to talk with each other, send the results and so on. Other than that, all the logic, i.e. picking up an answer and then exiting once the game is over, and everything happens very similar to users, but on all these things needs to be automated. So what I do is, the moment you create a game, I spawn multiple Go routines in a ticker, and it keeps answering the question, and the usual concurrency stuff like wait group, ticker. This ticker I'm using it for this timing, 10 seconds, 15 seconds, 30 seconds. Based on the type of bot, this ticker ticks the appropriate bot to answer. And these bots and the humans talk with each other using Golang channels. These are very usual stuff on how you run things concurrently. This Golang backend, the database that I'm using here is Redis / in-memory Golang and PGSQL. So I use Postgres as well as Redis and in-memory. This in-memory Golang in itself is a good fit for me because the sync package is really good. All I need to do is build a sync map and start using it. But once you need to move across multiple VPCs, suppose I am now the game is in this VPC, and so it is stored in memory inside this VPC. So what will happen when I horizontally scale in the future? I need the data. So for that reason I have this Redis DB as well, which I would which in future if there are multiple machines that I boot up can communicate with it and get in-memory data. Why there is an in-memory DB here? I have lot of reads than writes here. So for that reason, this Redis or in-memory database suits my use case. I can quickly read from the DB and then start using it. Once and there is this checkpoint where the data gets stored in my PG-SQL safely. So I am not using a third-party vendor like Neon, Supabase. Now even last week, I think 2 days back, PlanetScale is also supporting PG-SQL. But I am just doing the classical way of Docker container. I did boot up an PG-SQL image. Wrote a bunch of migration scripts for backup as well as recovery. Initial setup as well. Suppose you have the 6-7 bots, right? You need to store the bots your details in the database initially. All those use case. So there is this initial database setup, and then there is this migration scripts, and then there is backup and recovery which happens periodically. So I did boot up a Docker container, and then I have this PG-SQL image where I store the data. There are few columns which I indexed it so that I can quickly fetch data. So the another part I missed is logging, telemetry, database backup, DB recovery. So I've extensively logged everything here because now since it is not just a pet project and it is out that people can use it, I wanted to make sure that if something fails, I need to know what exactly happens. So I've extensively logged at every single layer, every single place, and it has helped me quite a lot. So what I didn't hand roll logger, or I didn't use the log package which is in Golang. Rather I used a logger called a Zap logger. If you've seen my older videos as well, I am a huge fan of Zap logger. This Zap logger is by Uber and they use it for their tech stack and it is open source. So I use this Zap logger for logging and telemetry, because once you put a product out, even though there is no paid feature as of now, I wanted to make sure it is up, it is running, and how good it performs. So this telemetry really helps. So once the server is up and running, we need to make sure that things are constantly working 24/7. We can't keep looking at it. So we have all different kinds of tools to make sure things are up and running. Like I have set CPU as 75%, and if it is 80% storage full, and how much GB RAM is being used, and so on. And I use Grafana here, Grafana cloud here, to observe all this data. Because since this app has heavy Go routine and concurrency, so I need to make sure that the code I wrote is correct, and there is no memory leak here, because the odds of memory leak is very very high. So what memory leak is, you hold some part of a data and you never release it back. into the system. Like if you are into C programming, you know this, so malloc or something, and then you finally free the memory. See, the Golang GC is really good, but still you need to make sure that things there is no memory leak. Even though the Golang does a lot of things really well, they have an extraordinary garbage collector. Suppose you have an in-memory sync map in Golang and you store some value, and all you need to do is replace this value with nil, and garbage collector would happily take care, do whatever it needs to do, free up the memory and do everything for you. Grafana helps me with this because I could see the memory usage, and if it keeps improving, and that means there is some memory that is not being freed, and I can go look into the system and make sure if some kind of logic, if there is some kind of a logical error, I can fix that. So that's the reason. That's the other reason why I use telemetry, and the major reason is somehow people start using it or something went down, I would get email and call. So make sure that I can beef up the machine. At least for now, all I can do is beef up the machine. But in future, I can add multiple machines. Make sure things are working fine. And final thing is DB backup. Already we are in the mercy of AWS Jeff Bezos. Suppose there is some technical error from my side and I crash the whole machine, or I unknowingly delete the whole volume, EC2 volume. Something can mess up, and to be safer side, I am taking DB backups. What I do is I run an systemd timer. So this is my PG-SQL. This is my systemd timer. What it does is it takes the backup out of my PG-SQL. So since I have less than 1000 or I didn't look at it, but I have less than 1000, 1500, few thousands of max lifetime users. So for me it is very easy to take a dump out of this file. That is, in a simple term, suppose my PG-SQL has around 10 tables and it has few thousand rows. So what I do is I take a dump, that is I take all the data out of it in the form of .SQL file. So next time what I need to do is I just need to run this .SQL file, and that is enough for me to recreate this whole database. So I take this dump. Since I'm doing it for the first time, I directly put it into an S3 bucket, compressed S3 bucket. So and that's the backup A. And after a while I just take a backup again. So that is backup B, and I do an SHA-256 of this backup A and SHA-256 of this backup B, and I will make sure that both backup A and backup B are same. That is, ideally if there is no user used in this period, there won't be a change in the database. So both this backup A and backup B will be same. At that time I don't push it to S3 bucket. I would make sure if there is a difference between two consecutive backups, only then I will push it to my S3 bucket. I just named it and I am storing it day wise, and I do backup like once every hour, and even that is bad. So if you lose anything within an hour, you won't be able to get it, but that's okay, you can always decrease the time. So I think I have covered almost everything in this video. So these are the things that went behind building that simple game. Hope you like this video. I'll get back to you guys soon with another video. Thank you.